This video is entitled Measures of Position for Data Sets. Just sort of helps indicate where a data value lies in a data set, similar to z-scores, but a little bit different than that. So the first type of measure of position for a data value is called percentile. I'll often ask students, before I show this definition, what do they think means percentile means. Some will know, some don't. Like if you said, I took a test and I was in the 75th percentile, what did that mean? Well, one thing it does not mean you got 75% of the questions right. That is not what percentiles mean. Percentile is actually a ranking value. It's therefore a position. And a lot of times they use this P with a subscript. So if you saw a P with lowercase subscript 32, that would be 32nd percentile. And then you see I have written in words right there, for example, the 85th percentile. Means that 85% of the values are less than the value that represents that percentile number. So like I said, if you took a standardized test, for example, like an SAT or GRE, and you were in the 85th percentile of whether math or verbal or whatever, that means you did better than 85. Your score was higher than 85% of the people that took it. Percentiles are actually, fairly commonly used. I've heard of them being used, for example, talk about like baby development or whatever. Take some little baby in at a certain time, maybe at 10 weeks, your baby is in the 55th percentile for weight and 62nd percentile for length. So obviously babies aren't vertical yet, so you don't measure them by height, you measure them by length. But yeah, so I guess that's not a big deal, obviously. But I guess weight would be the bigger concern. But anyway, so yeah, that's what that means if they report that kind of data back to you. So of all kids measured in that group, tells you you're larger than that. So it's not always good or bad. It depends on the percentile issue. But like I said, higher is not always better. Depends on what that data represents. Like I mentioned in my video for variation, using the electric bill example or whatever, I would be very happy if I was only in the 10th percentile for an annual electric bill in the summer. I'm pretty sure I'm not, but that would be ideal because that means 90% are paying more than you are. So okie doke, let's look at how you can calculate these specific percentiles. I'd like to show you this. We're going to do something called quartiles here in a minute. I want to show this, even though I'm not likely to ask this on an exam, but I just wanted, at least I thought it was good to show, good for you to data set to get we're going to be doing percentiles actually for the bell-shaped distribution later on in the second part of the course. I'm talking about for percentiles for these individual values. Well, what you do is you take you sort the data, you take your percentile value and you multiply it by the n, the number of values in your data set. And then you go to the L, this value L here tells you the next integer past that number. In other words, I'll show you what L is here in a minute. L doesn't mean that's your percentile value. It's actually the number in the list. But so here's a data set all listed out in order. And they said that they want to find the 40th percentile. So they took 40%, 40 over 100 times 20, and that ends up being exactly 8. Sometimes they would be exact, sometimes they wouldn't be. But whether it's rounds perfectly or not, or calculates to be a whole number, you go to the next number above that. So even though that's 8, we don't use 8, we go to 9. If that would have been 8.2, I would have gone to 9. If that would have been 8.8, I would have gone to 9. So 9 means, L is 9, that means your percentile is the 9th location of this data set, which is very important that this is sorted. So you go to the 9th number, 3, 5, 6, 8, 9, that's a 6, here's the 7th, here's the 8, here's the 9th right there above my box there. It's the 14th. The 14 is the 9th number in the list. So here they did a 73rd percentile. So they took 73% times 20. Obviously they converted to decimal. Got 14.6. So that means your 73rd percentile value will be the next integer above that. So you don't round down to the nearest integer. You automatically go to the next integer above it. So like I said, if that would have been 14.1, I would have picked 15. Well, just like the exact last example, if it would have been 14, I would have picked 15. But anyway, so it's the 15th number, which you do 10, here's 11, 12, 13, 14, 15. So it's at 28 right there above my box. All right, so just wanted to show you that. Now I'm going to show you what we are going to be calculating or having to do for exam purposes. We're going to find these 3 specific percentiles, but without using that formula above. We're not going to use that formula. We're going to be able to do this just by using medians. Or if you have the technology in the calculator, you can do it in the calculator. That's fine. I'll show you that too. But if you're not using the TI 83 or 84 or even higher, some of the newer models, then we're going to look at how to do it manually also. So we're going to find these 3 quartiles, Q1, Q2, Q3. Q1 is the first quartile. It's the 25th percentile. Q2 is the second quartile, but guess what? We've already done this one before. It's the second quartile. It's the 50th percentile. It's the median. So we've already done that. And the third quartile will be the 75th percentile. So the way you do this is we're going to use medians to sort of essentially chop these in halves into quarters. So actually the way you do this is you don't find these in order as listed, Q1, Q2, Q3. You actually find Q2 first, the median. You find the median of the entire data set first, and then you split that into 2 halves, and then you find the median of the lower half, which will be Q1, and the median of the upper half, which will be Q3. So you chop it in half, and then chop each of those halves in half. And there you go. Now it's a little bit different based on whether you have even or odd numbers in your data set. So it can be, like I said, if you're using a calculator, you don't care. But let's see. I'll run through one of these in the calculator. Well, there's the outputs, but I'll show you how to. It's that same one-var stats command. So here are these numbers. 17, 1, 5, blah, blah, blah. I'm going to write these down real quick when I'm talking so I can put them in the calculator faster. So you got to sort them. So take a look at what I did there as far as the sorting. Now when you put them in the calculator, they do not have to be sorted in the calculator, but they do if you're just doing it by using medians. So they're sorted. And then I look for my overall median. Sorted, which is at 9 right there. So we had an odd number of values, meaning we would have a single median. So, we'll talk about when we have an even number of values here in a minute, just like we had before. But so that means your Q2 is 9, your median, your overall median. So each half needs to have the same amount of values. So if your data set is odd like this, you'll find that median and throw it out. No, we don't know what to throw it out as far as, not the answer, but you use it for Q2, but then we throw it out as far as finding Q1 and Q3, as indicated by my parentheses. So my parentheses are basically grouping off the first half of the numbers and the second half of the numbers. So we go to these first half of the numbers. There's 7 of them. So once again, that's going to be odd. So you will find one number in the middle. That's your Q4. Q1, which is 4, it's the middle number. And then the upper side, you have 7 numbers. The middle number is the first 12. So that's your Q3. So you see that the calculator shows Q1. It doesn't show Q2. It shows median, but that is Q2. So 4, 9, 12. And in fact, this whole thing, this whole output, we'll see that coming up here shortly, but that's called the 5-number summary, where it shows minimum value, Q1, Q2, Q3, and the maximum value. That's going to be used for a certain type of plot graph we're going to see shortly. All right, I'm going to try to decide if I want to do this one or just do, so you see I have all the outputs, but I don't have any of them. Just see if there's any other example I could use. Oh, here's one where I sort of showed, that's a graph, but yeah, I could just do this one we just did, especially since I just wrote the numbers down. So I'm going to enter these in there. You'll see me enter them. And like I said, since I wrote the numbers down, that's going to make it quicker. So otherwise, I would have to keep toggling back and forth to the notes. So let's clear that out. Stat, edit, list. Okay, now, like I said, I could clear that list if I want to, but since I know I'm typing in more numbers that are already there for sure, I'll just type over them. But you could clear it first. See, I'm going to put 17 in there. Just keep hitting enter. 1, 9, 3, 4. So notice they're entered in there in the original way they were in the list. 10. The calculator will sort them. 12. I need to be careful because sometimes it's using the buttons on the computer screen. It's easier for me to use a calculator with the buttons by hand. Sometimes I'll think I've tapped the number and I haven't. I think I'm doing okay so far. And of course, I don't have any students to help correct me while I'm doing this either. So 8. All right, we'll know when we get the answer. 13, 2, and 7. So that's the 15th number. So see, now it's looking for the 16th. So the fact that's blank with 16, L1 16, that means there's 15 numbers in that list. So now I'm going to quit out of that. That's there. I'm going to go stat, calc, 1var stats. Hit enter there. I don't know what that does, but obviously it hasn't affected us by leaving it blank. Calculate. So obviously there's all our standard deviation stuff that we talked about in the other video. But I'm just kind of scrolling down for what we need right here. And there they are, the Q1, the median, Q2, and Q3, 4, 9, 12. So if you just want to use the calculator to do that, that is perfectly fine. Now to save a little time on this next example, went ahead and sorted the data for the rest of these so we didn't have to just sort them every time. It's a little tricky probably with all these drawings. I wish this was a tablet so I could, but if I try to erase that and start over, it'll look terrible. Now, this is one where we had an even number of values here. There's 8 and 8 or 16 numbers. So the Q2, yes, I see I wrote right down here, is the way we learned in that other video on mean, median, and mode, central tendency, is we take the middle two, 7 and 9, add them together and divide by 2, gives you 8. Now this is an interesting scenario compared to the one like below here and then the one that with the first example. It makes sense when you have one number as your median that you would toss it out. You know, it makes sense. You have an even number of values on both sides. That seems logical. But this one, you could kind of make a case for 2 different ways to do this. There's only one right way, though, but there are 2 logical ways. You could say, well, I could throw the 7 and the 9 out completely. And I would have 7 numbers in the first half. And then with that circle part gone, I would have 7 numbers in the second half. That would make it symmetric. Seems logical, but it's not correct. When you have to average the middle 2 numbers to get the median, what you do is the first number of the 2 that you average, in this case the 7 belongs to the lower half of the data. So you see I have the bracket from here and then close a bracket there. That's what the brackets represent. The 7 belongs to the first half and then the 9 belongs to the second half. So we don't throw them out. We keep one for the lower, one for the upper. So now we have to be careful when we do this because remember that 7 counts. So we have now 8 numbers in the first half. So once again, it's even. So I'm going to have 2 numbers to average. So the 4 and the 5, 4 plus 5 divided by 2, that's 4.5. So that's your Q1. Then you come over here, the 4th and the 5th, or the 10 and the 11. Average those, you get 10.5. And of course, you don't see the numbers in the list, but they were there correctly. So that's what obviously that's what the calculator's doing too. It'll take the first one for the lower, second one for the upper. But there they are, 4.5, 10, 8, and 10.5. Okay, so here's another. That I think example 3 is pretty straightforward, pretty easy. Example 4, once again, we got 2 of them. So we took the middle 2, averaged them to 6.5. And the 6 goes to the first half, the 7 goes to the second half. So the middle 2 here are both 4s. So obviously, if they're the same number, that's going to be, that would be the average. So 4. Here we have a 9 and a 10. So you add those together, divided by 2 is 9.5. All right. So fun with quartiles. Now we have a unit of measure called interquartile range. Really easy to calculate. It's just Q3 minus Q1. So if you have a question on test that says find IQR is the shorthand name for this. Perhaps I should include that here. Let's see. I think I can do that without messing this up. So if you get the Q3 and the Q1 right, it's no problem. So if the problem says find the IQR, you get Q1, you get Q3. Of course, you would have gotten Q2 anyway, but although it was there. Okay. All right, so it's Q3 minus Q1. Now, this next part I don't directly ask on a test, but I just wanted to show you because I've talked about in other videos about outliers and wanting you to be familiar with the concept of them more than calculation. Only calculation we've sort of seen that with the empirical rule that anything outside plus or minus 3 standard deviations will be an outlier. For this, you can kind of think an outlier, if you take Q1 and you subtract just 1.5, that's an arbitrary value that was just developed. So you might wonder, where's the 1.5 come from? That's just the formula, so it would be 1.5 every time. So you take Q1 minus 1.5 times IQR. And any number lower than that would be considered an outlier. Or if you take Q3 on the upper end and add 1.5 times IQR. Anything larger than that, anything greater than that would be considered to be an outlier. So let's look at this data set and see if there's any outliers. Well, we're going to calculate it, but I think it's pretty obvious that 2 would be an outlier. But 30, see, 30 is kind of, not obvious. Like if it was 300 or something like that, blatantly obvious. You might think, that's kind of out there, but is it out there sort of thing? So if you were really determined or whether or not that was going to be an outlier or not, you could do this test right here. So the quartiles are easy to find. So IQR is Q3 minus Q1, so it's 14 minus 5, which is 9. So then I just took 1.5 times 9 to get 13.5 because that's that same measurement used in both results here. So if you take Q1 minus that 1.5 IQR, which is 13.5, you get negative 8.5. If you take the Q3 and add to that, you get 27.5, not 13.5. So what we're saying is we would consider any number smaller than negative 8.5 to be an outlier, or anything larger than 27.5 to be an outlier. So obviously the low end, there's nothing smaller than negative 8.5. So actually in this case, since 30 is larger than 27.5, we would go ahead and rule that as an outlier. But had that been, let's say, 26, for example, or even 27, it would not have been an outlier. according to that test. Now here's another one. Once again, now the 30 is probably obvious. It wouldn't be an outlier, but 2 maybe. But here's the IQR is 24 minus 14, which is 10. 1.5 times that IQR is 15. 14 minus 15 is -1. 24 plus 15 is 39. So anything outside of the boundaries of -1 to 39 would be outliers. So no, the 2 would not be considered an outlier. It would have to be something smaller than -1. 30 wasn't really an issue, but I'll mention anyway. 30 is not an outlier. We knew it wasn't pretty much just by visual inspection. Now here's that 5-number summary thing I told you the calculator will spit out, or you can do it manually. So here's a little data set that we concoct the 5-number summary. And here's a new type of graph called a box and whisker plot. So the way to construct a box and whisker plot, and when I say construct, once again, all you have to do is pick the right answer on a test, which one would be the right box and whisker plot based on the numbers for the 5-number summary. You don't have to draw it. This is just, I did it in the TI calculator. Now, I don't know why it puts it up there. This graph does not really have a y-axis value. There's no values on the y-axis. It's all on the x. So I don't know why it puts it at that height. That I have no idea. So the 5-number summary for that data set up here. Okay, so what you got here? We got the median would be 6.5, so that's Q2. So then you see you split them in half. The first one belongs to the lower, second to the upper. 5 and 5 is 5. 7 and 8 would average to be 7.5. So here's your 5-number summary. So the way you draw this is just kind of above the x-axis somewhere. So I didn't draw all the points. I just put all the key ones there, but just a number line basically. 3 to 11, obviously we know that's our min to max. So I didn't have to really go outside that. So I just drew a straight line somewhere up a little bit above the axis. Draw a straight line, and you just put dots to where all those 5 numbers fit. Minimum, Q1, Q2, Q3, and max. So it's a straight line with dots. Then you draw a box around Q1 to Q3. So once again, the box, it could be skinnier, that's not important. It just goes from Q1 to Q3. So if the box was a little flatter, a little steeper, that's all right. So you draw a box around this, and then you put a line in the middle for the median, and that shows you, so it shows you Q1, Q2, Q3, with a little box. So you see it's got a box in the middle, and the 2 parts sticking out on the outside are its whiskers. So isn't that delightful? So obviously, if you saw a box and whisker plot, even without any numbers, you saw a box and whisker plot that had a really, really, really long whisker on it, yeah, the end of that whisker would be an outlier. Now, so your data is broken up into quarters here, with these quartiles. So what I'm showing you here in this drawing has nothing to do with the size of the boxes or whiskers. I mean, the size is based on the numerical values. And what I mean by that is, for any data set, this is true, has nothing to do with this particular result. Since Q1 is the 25th percentile, you would always have 25% of your data that fit between the minimum up to Q1. And then from Q1 to Q2, you have 25%, because Q2 is 50%. So you see it's like a running total. Since Q3 is 75% total, that means it would be 25% between Q2 and Q3, and then 25% from Q3 to the max. So you see it has nothing to do with the width of that at all, because it's just the number of values are the same in each region. You break them into quarters. You have, like for this one, okay, that relates to this one, so let me just show you. For this one, so the first 4 numbers are 25% of your data. That fits in Q. And the second 5 are 25%. That's from Q1 to the median. The next 4 are from Q2 to Q3. And the last 4 from Q3 to the max. So there are 4 numbers represented. 25% of the 16 numbers. Okay. And it looks like we have another example. I just showed the commands to do the plot for the box and whisker. But frankly, you don't really need to do that, because all you got to do is, if you want to use the calculator to this part right over here, to where you get the 5-number summary like we've done, you get this part. I was just showing how it draws it, but it's not important. All you got to do is get that 5-number summary, and then you would be able to pick the right answer out for whatever the whatever the right box and whisker, because it would have the x-axis would be labeled. I'm wondering if my y max being 5, that probably has something to do with my box and whisker plot, how high up it goes. If I put a lower number there, it would probably display it lower, obviously. So, but it has no meaning other than that. So the graphing of this in the calculator, I don't think is important. All you got to do is get those numbers and pick the right result, and you'll be good. And that looks like that concludes measures of position.